Myself, Dhruv Kumar, working in Mechanical Engineering Department in IIMT College of Engineering. Today video lecture I will explain introduction of the cam and follower. So definition of the cam. Cam is a basically rotating machine element which gives reciprocating motion to the follower. So cam basically we will talk about the cam and follower. Complicated motion can be achieved with the help of the cam and follower arrangement. So if there is a line contact between the two elements, so they are categorized as a higher pair. Cam are usually basically rotating at uniform speed, and follower have a motion rotating, reciprocating as well as oscillating. Example of the cam. Cam are widely used for operating the inlet and exhaust valve of internal combustion engine, and automatic attachment of the machine, paper cutting machine, spinning and weaving textile machinery, feed mechanism of the automatic lathe machine. Here you can see the animation where inlet and outlet always operated by the camshaft. Classification of the cam mechanism. Um, Based on the modes of the input and output motion, cam are classified as a rotating cam, translating follower, rotating cam, oscillating follower, translating cam, and translating follower. In rotating cam, translating follower, the cam have motion in rotary and follower is have motion in translatory. And second one is rotating cam, oscillating follower. Here the cam have a rotary motion and follower have the oscillatory motion. Third one is the translatory cam and translatory follower. In this type of cam and follower arrangement, the cam have translatory motion as well as follower is also have the translatory motion. Cam is also categorized according to shape of the cam, and according to shape, these are wedge cam, radial or disc cam, cylindrical cam, spherical cam. Wedge cam basically have the cross section in the form of the wedge, and desired motion is obtained with the by the changing of the follower arrangement. In first type of wedge cam, here wedge is basically have the translatory motion, and cam are fixed with the spring and have some guided element. When wedge is translating, the cam is also have the translatory motion, and there is the point contact between the wedge surface and the follower elements. So in second example, by the translatory motion of the wedge, the cam edge have the the follower have the oscillatory motion by changing the some arrangement. In third one, the cam wedge cam have the translatory motion, and follower is also have the translatory motion. Another type is radial or disk type cam. Radial cam are those type of cam in which the follower moves radially from the center of rotation of the cam. These are the very popular due to its compactness and simplicity. A radial cam converts a rotary motion into the translatory motion of the follower. So basically, the surface of the radial cam is in the form of the disc, and desired output motion is obtained the follower, and these are basically very popular due to its compact size and its simplicity. Another is a cylindrical cam. the type of cam basically consists of the circumferential contour cut in the surface with rotate about the axis. There is a groove cut on the surface of the cam and the roller has a constant or positive oscillating motion. In this type of the cam, the circumference of the cylinder has a working surface and groove cut on the circumferentially, and roller follower is fixed on this groove. So positive, basically positive oscillating motion is obtained in this type of the cam and follower arrangement. Another type of the cylindrical cam is end cam. In this type of the cam arrangement, the working surface of the cylinder is the end surface. So end of the cylinder, which is the working surface, is the end cam, and the spring loaded follower has the translatory motion along the parallel to the axis of the rotating cylinder. So when cylinder is basically rotating, the follower have the translatory motion parallel to the axis of the shaft of the cylinder. This type of the cam also known as the barrel or drum cam. Spherical cam basically have the shape of spherical, and oscillating motion is obtained by the follower by the fixing of the follower end in the groove of the spherical surface. So spherical cam is in the form of the spherical shape in which the groove is made. Follower has the surface contact with this groove. As cam rotate, follower oscillates about the fixed point. Next one is the classification of the follower. So follower is classified according to many ways. First one is the according to the shape of the follower. So first one is the knife edge follower, next roller follower, next flat faced follower, and last one the spherical faced follower. So basically, follower is categorized on the basis of the end surface of the follower. If end surface is in the form of the knife, then it is called the knife edge follower. And if end surface is in the form of the roller, then it is called the roller follower. So when the contacting end of the follower is a sharp knife edge, then it is called the knife edge follower. This is the simplest among all the follower, and these kind of follower is not used in case of the first application because of the sharp edge. So if you talk about the knife edge follower, um, the contacting end basically have the knife edge, and basically translatory motion take place between the these type both type of the surface. So due to the wear and tear at high speed, the type of follower is not used in high speed. So by using the roller follower, we can avoid such type of the problem. So when the contacting end of the follower is a roller, then it is called the roller follower. This type of follower is mainly used in high speed operation because it has a smooth contact with the surface. This type of follower, these type of follower basically used in internal combustion engine where less space is required, and less wear and tear is required in both the surface. Next one is the flat faced follower. When the contacting end of the follower is perfectly flat face, then it is called the flat face or the mushroom follower. This type of follower looks like a flat surface with an irregular cam. This type of cam is used when the space is limited and this follower can resist more side thrust. So when the end surface of the follower is in the form of the flat uh, disc, and this type of follower is used when less space is required. There is a drawback of this type of follower. There is a contact stresses is more in this type of follower. So these limitation is reduced in the spherical phased follower. When the contacting end of the follower is a spherical shape, then it is called the spherical follower. This type of follower has the curved but regular follower as well as cam. This is the modification of the flat-faced follower, where the drawback of the flat-faced follower is minimized in the spherical phased follower. Follower is also categorized according to the path of motion of the follower, and there are two types: radial follower and offset follower. In radial follower, when the motion of the follower is along its axis passing through the center of the cam, this is known as the radial follower. You can see in the diagram, when axis of the follower is passing through the center of rotation of the cam, then it is called the radial follower. In case of offset follower, the axis of the follower is passing through the some distance from the center of rotation of the cam, then it is called the offset follower. Next is cam nomenclature. Basically, cam we can design the cam and follower with. So first we study about the cam nomenclature. Without study of the cam and nomenclature, you cannot draw the cam profile. So this is the very important aspect of the cam and follower. So first is the cam profile. You can see here the dark curved surface, yeah, dark disk. Yeah, we can see that the outer surface of the cam. So that is called the cam profile. Here, this is the roller follower. So cam profile is the basically outer surface of the disc cam. So this is the dark profile. You can see this is the cam profile. Next one, the base circle. So we can draw the base circle with the help of the cam profile. Basically, base circle is the minimum radius circle, which is the uh, tangent to the cam profile. Yeah, it is the minimum radius of the circle of the cam profile is known as the base circle. Next is the trace point. Basically, if we will talk about the roller follower, the center of the roller is known as the trace point, and in case of the knife edge follower, the tip of the knife is known as the trace point. So, trace point, it is the point on the follower and its motion describe the movement of the follower. It is basically used to generate the pitch curve. So, here how to generate the pitch curve? So, basically pitch curve is generated by using the motion of the cam profile is constant and the follower is moved around the cam surface. So the profile traced by the trace point is known as basically pitch curve. So the pitch curve is the basically path generated by the trace point as the follower is rotating about the stationary cam. I have already discussed that when cam is stationary and follower is moved around the cam. So the profile traced by the trace point is known as the pitch curve. Next one is the prime circle. Prime circle is basically smallest circle from the center of the cam through the pitch karo. Yeah, we can say that it is the minimum radius circle which touches the pitch karo. Next one is the pressure angle. Basically, pressure angle is the angle between the axis of the follower and normal to the pitch curve. If we will draw the line normal to the pitch curve, as you can see, the angle between the axis of the follower and pitch curve is known as the pressure angle. And if we will talk about the whole surface, there is a one point where pressure angle is maximum. So basically trace point is converted to the pitch point. So we can see that um, those point where pressure angle is maximum, so trace point is converted to the pitch point. And if the circle is drawn to the center of the cam and radius as a radius up to the pitch point, that circle is known as pitch circle. So you can see that this is the pitch circle. Next one in the stroke, basically greatest distance or the angle through which the follower moves or rotate. If you will talk about the follower motion, there are three type of the motion: rise, fall, and dwell. Basically, rise movement of the follower it take place due to the rising surface of the cam, and down movement of the follower is take place due to the downward profile of the cam, and dwell is the period in which the cam is rotating but follower motion is constant. So according to this type of the motion, we can categorize there are three type of the angle: angle of ascent, angle of dwell, and angle of descent. So angle of ascent is the angle through which the cam turn during the time of follower rise. Angle of dwell is the angle at which the cam is turning but follower motion is remain constant, and angle of descent is the angle in which the cam is rotating and follower return to its original position. So next is the type of the follower motion program. There are we will discuss here only three type of follower motion program: uniform velocity, simple harmonic motion, and uniform acceleration and retardation. In a uniform velocity motion, the displacement of the follower basically proportional to the angle of rotation of the cam. So the if we will draw the curve between the angle of the rotation of the cam and follower displacement, the curve is a straight line. Due to the straight line curve, there is a jerk produced at the beginning and last moment of the follower displacement. So this type of the follower motion program is not used in the high speed. Next one is the simple harmonic motion. Since the follower moves with a simple harmonic motion, therefore velocity diagram consists of the sine curve and the acceleration diagram consists of the cosine curve. Here you can see that there are two types of angle. there are two types of angle. One is the angle of ascent, another is the angle of return. And so you can divide the angle of ascent and angle of return to the equal number of even parts. You can start from the 4, 6, 8, and in the uniform acceleration and retardation diagram, the moment of the motion of the follower in first half is in acceleration, and in the later half of the first half is in the retardation motion. So point is marked on the diagonal first, second, and third diagonal line and vertical line, and curve is drawn in this way. Cycloidal motion is the basically very smooth curve, and you can use such type of motion curve in the high speed type of cam. So here I have draw the cam profile. In the here I have taken the example of the knife edge follower and radial cam. So cam is divided in the there are three types of angle: angle of ascent, angle of tail, and angle of return. And angle of ascent and angle of return is divided into the equal number of parts. So you can start from the even number of parts. So I have divided six number of parts, and basically follower displacement is taken from the displacement diagram. So A, B, C, D, E, F. These point is marked from the follower displacement diagram, and each point is joined with the help of the curve. So curve obtained is known as the cam profile. So thank you very much.